Welcome to lecture series EPG Padasala for Computer Science. In this lecture, we will be discussing the cost of software quality. Learning objectives: outline the objectives of costs of software quality measurements, compare the classic quality model with the extended model, describe the process of implementation of costs of software quality system. Major content of this presentation has been prepared from the textbook Software Quality Assurance from Theory to Implementation, authored by Daniel Gellin, Pearson Education Limited, 2004. Introduction: commercial companies or public organizations require economic evaluation of their quality assurance system. Cost of software quality may be viewed as another class of software quality metrics, where financial values are used and as the measuring tool. Quality metrics and costs of quality both support management control and decision making process. We are aware that quality attributes should be incorporated from the first stage of the software development life cycle. We need a team of qualified personnel, well trained, well equipped human resources to perform the system analysis, study the existing system, identify the drawbacks of the existing system, come out with the anticipated advantages of the proposed system, and finally prepare the deliverable, the software requirement specification document. Only if the software requirement specification document is prepared carefully, considering all the requirements, we will be able to deliver a quality assured software product. Cost is incurred at this stage also. Once the software requirement specification document is ready, you need a sound design team who will translate the software requirement specification document into a design document. The design document has to be reviewed for quality, and only if the design is carried out with well defined standards, you can enter into the coding phase. Here too, we need experts who will translate the design into code. Check has to be done whether coding standards have been adapted. Once coding is complete, we enter into the testing phase. Testing can be done by the programmer while he or she is coding a module. Once modules are complete, an independent test group can test the software. 1, 2 or more teams may be employed to test the same software. Cost is incurred at this stage also. Once testing is complete, the product is deployed and we enter into the maintenance phase. Each stage, to maintain the quality of the software, expertise is required, which incurs cost. Cost of software quality metrics. Objectives: enables management to achieve economic control over software quality assurance activities and outcomes. The major objectives are control organization initiated costs, to prevent and detect software errors, evaluation of the economic damages of software failures as a basis for revising the software quality assurance budget, evaluation of plans to increase or decrease software quality assurance activities or to invest in software quality assurance infrastructure on the basis of past economic performance. Now, let us look into the classic model, which is also named as Feigenbaum's model. The classic quality cost model developed in the early 1950s by Feigenbaum and others classifies costs related to product quality in two general classes: costs of control and costs of failure of control. Costs of control include costs that are spent to prevent and detect software errors in order to reduce them to an accepted level. Now, how do I define this accepted level? It depends upon the application. In certain real-time applications like flight control, what will be the acceptance level? I can state that there must not be any failures. There must not be any failures. So, rigorous testing has to be carried out. Consider another example, a billing system in a supermarket. There you can define an acceptance level. A small threshold value. Cost of failure of control. Cost of failure of control include costs of failures that occurred because of failure to prevent and detect software errors. Here we are able to see the diagrammatic illustration of the classic model: costs of software quality, costs of control, costs of failure of control. When you come into costs of control, we have prevention costs and appraisal costs. When you look into costs of failure of control, we have internal failure costs and external failure costs. The model further subdivides these classes into subclasses. Costs of control, as I have mentioned in the previous slide, prevention costs and appraisal costs. Costs of failure of control, internal failure costs and external failure costs. Coming into prevention costs, investments in quality infrastructure and quality activities that are not directed to a specific project or system. Appraisal costs, the costs of activities performed for a specific project or software system for the purpose of detecting software errors. Coming into the types of costs of failure of control: internal failure costs, costs of correcting errors that have been detected by design reviews, software tests, acceptance tests and other tests that have to be completed before the software is installed at customer sites. External failure costs, all costs of correcting failures detected by customers or the maintenance team after the software system has been installed. Now, coming into external failure cost, consider a software product has been deployed. over a period of time bugs have been detected. Now, the bugs detected may be an outcome of understanding the requirements wrongly. The team which has prepared the software requirement specification document would have misunderstood certain requirements and recorded it wrongly. This is carried out in the design phase, coding phase, and finally the project is deployed. So, when you talk about external failure cost, it depends upon the degree to which where corrections have to be made. If the corrections have to be done from your design document, the cost involved will be high. The reason is the design team has to look into the reasons why the design is deviated, correct it, then the coding team has to modify the application program, the testing team has to retest, check for ripple effects if any, and then deliver the product. So, as mentioned, all costs of correcting failures detected by customers or the maintenance team after the software system has been installed will generally be high, because considerable amount of time, human resources has to be spent in fixing the bugs and again deploying the product. Prevention costs, investments in development of software quality assurance infrastructure components, procedures and work instructions, support devices, templates, checklists, etc., software configuration management system, software quality metrics. Coming to regular implementation of software quality assurance preventive activities, consider new employees. Appropriate instructions have to be given to new employees in software quality assurance subjects. If necessary, certification of employees must be obtained. Next, control of the software quality assurance system through performance. The major three things which are considered here are internal quality reviews, external quality audits, and management quality reviews. Appraisal costs, costs of reviews. Here we have formal design reviews, peer reviews, inspections and walkthroughs, expert reviews. Cost of software testing, unit integration and software system tests, acceptance tests carried out by customers, costs of assuming quality of external participants by means of design reviews and software testing. These activities are applied to the activities performed by subcontractors, suppliers of customized on the shelf software systems and reusable software modules. The customer is also a participant in performing the project. Internal failure costs, costs of redesign or design corrections subsequent to design review and test findings, cost of reprogramming or correcting programs in response to test findings, costs of repeated design review and retesting. External failure costs. External failure costs entail the costs of correcting failures detected by customers or maintenance teams after the software system has been installed at customer site. Typical external failure costs cover resolution of customer complaints during the warranty period, correction of software bugs detected during regular operation, correction of software failures after the warranty period is over, even if the correction is not covered by the warranty, damages paid to customers in case of a severe software failure, reimbursement of customers' purchase costs, insurance against customers' claims. Examples of hidden external failure costs include reduction of sales to customers that suffered from software failures. As an example, a company has developed a transaction processing system for an organization. The organization which uses the transaction processing system suffers frequent breakdowns. Due to this experience, the organization may not utilize the services of the company which has developed the online transaction processing system for other projects. In addition to this, the organization may give a negative feedback about the company which has developed the transaction processing system to other organizations. As an outcome of this, there is a considerable reduction in the projects which the company would have developed in future. Severe reduction of sales motivated by firms' damaged reputation, increased investment in sales promotion to counter the effects of past software failures, reduced prospects to win a tender, or alternatively the need to underprice to prevent competitors from winning tenders. In some organizations, they blacklist the companies which have supplied products which are of poor quality. They may blacklist for a particular period of time or take a policy decision that they will not involve the company in the future projects. Now we will discuss the extended model for cost of software quality. Analysis of the software quality costs defined by the classic model reveals that several costs of substantial magnitude are excluded. Typical software quality failure costs include damages paid to customers as compensation for late completion of the project due to unrealistic scheduling, damages paid to customers in compensation for late completion of the project as a result of failure to recruit sufficient staff. The element common to these two failures is that they result not from any particular action of the development team or any lack of professionalism. They are actually outcomes of managerial failure. Management can perform several activities to prevent or reduce the costs: contract reviews, thorough appropriate progress control of the software project. Now we will discuss the extended model for cost of software quality. We have already discussed costs of software quality. We have costs of control and costs of failure of control. And in the previous model we have discussed prevention costs and appraisal costs. In addition to prevention costs and appraisal costs, in the extended model we have managerial preparation and control costs. In the second case, in addition to internal failure costs and external failure costs, we have managerial failure costs, managerial preparation and control costs. Managerial preparation and control costs are associated with activities performed to prevent managerial failures or reduce prospects of their occurrence. If planning is done carefully, considering the situations, when I mean situations, availability of hardware resources, availability of software resources, availability of human resources and other resources that may have an effect on project development, we can take care that the project progresses as per schedule. Typical preparation and control costs include costs of carrying out contract reviews, costs of preparing project plans including quality plans, costs of periodic updating of project and quality plans, costs of performing regular progress control, costs of performing regular progress control of external participants' contribution to the projects. Managerial failure costs. Managerial failure costs can be incurred throughout the entire course of software development, beginning in the pre-project stage. Typical managerial failure costs include unplanned costs for professional and other resources resulting from underestimation of the resources in the proposal stage. Damages paid to customers as compensation for late project completion, a result of an unrealistic schedule in the company's proposal. Damages paid to customers as compensation for late completion of the project, a result of management's failure to recruit sufficient and appropriate team members. Next, domino effect, damages to other projects performed by the same teams involved in delayed projects. A delay in a project which a team is working with will affect the project the team is supposed to work immediately after completion of this project. Application of a cost of software quality system. In order to apply a cost of software quality system in an organization, the following are required: definition of a cost of software quality model and specification of cost items. The organization should select the classic or extended model. Definition of the method of data collection for each cost item. Use of a management information system or a decision support system or an executive information system. Application of a cost of software quality system including thorough follow up and the actions taken in response to the model's findings. At a preliminary stage in a project, the organization has to choose its type of cost model, the classic or the extended model. Effectiveness of the selected model is determined to a great degree by its suitability for the organization or project of the cost items designed to be measured for the model. Each item should belong to one of the subclasses comprising the cost model. Definition of the cost data collection method. Once the list of software quality cost item is finalized, a method for collecting the relevant data must be determined. Data collection and analysis plays a major role. Improper or incomplete data collection will lead to a wrong interpretation. So, data collection plays a major role. One of the major issues raised at this stage is whether to develop an independent system for collecting data or to rely on the currently operating management information system. Use of management information system in place is preferable to creating new systems because of the following reasons. Expected savings in costs by running a working data collection system already operating instead of creating and running an independent system. Avoidance of disagreements in interpretation of data provided by the management information system versus the data provided by the independent system. Implementation of a cost of software quality system. Here, implementation of a new cost of software quality system involves assigning responsibility for reporting and collecting quality cost data, instruction of the team in the logic and procedures of the new system, follow up, support for solving implementation problems and providing supplementary information when needed, review of cost reporting, proper classification and recording, review of the completeness and accuracy of reports by comparing them with records produced by general MIS system and the cost and activity records from previous periods. Actions taken in response to the model's findings. Actions: improvement of software packages help function, increased investment of resources in contract review, reduction in instruction activities yielding no significant improvement, increased investment in training inspection team members and team leaders, adaptation of more intensive project progress control procedures, construction of certified list of subcontractors allowed to participate in the company's projects, introduction of automated software tests to replace manual testing with no substantial increase in testing costs. Now, when you consider the first action, expected result, reduction of external failure costs. Second action, reduction of managerial failure costs. Third action, reduction of prevention costs with no increase in failure costs. Fourth action, reduction of internal and external failure costs. Fifth action, reduction of managerial failure costs. Sixth action, reduction of failure costs, especially external failure costs. Seventh action, reduction of internal and external failure costs. So, these are the actions that has to be taken. Problems in the application of cost of software quality metrics. Application of a cost of software quality model is generally accomplished by problems which are caused due to inaccurate or incomplete identification and classification of quality cost, negligent reporting by team members, biased reporting of software costs, especially of censored internal and external costs, biased recording of external failure costs, hidden compensation of customers for failures. Problems arising when collecting data on managerial costs, contract review and progress control activities are performed in a part-time mode. Many participants in these activities are senior staff members who are not required to report use of their time resources. Difficulties in determination of responsibility for schedule failures. Payment of overt and formal compensation usually occurs quite some time after the project is completed and much too late for efficient application of the lessons learned. To summarize, cost of software quality indicates the economic assessment of software quality development and maintenance. Application of cost of software quality metrics enables management to achieve economic control over software quality assurance activities and outcomes. The classic model of cost of software quality is compared with extended model. Application of a cost of software quality model is generally accompanied by problems which are caused due to inaccurate identification of quality costs and collecting data on managerial costs. I acknowledge the authors of the books which I have referred and the web resources I have used for this presentation. Thank you.